Belajar je, Papa.
Hei, kebenaran datang sini bukan nak belajar lah. Kebenaran nak mulakan pekerjaan baru di MMU. Bye. Tata Titi Tutu.
Cik Papa, dah bersedia untuk hari pertama bertugas sebagai kaunselor MMU?
Sudah tentu. Kaunselor kebenaran tak pernah tak sedia.
Tumpah tanya, boleh tak terangkan tentang kemudahan yang ada dekat MMU?
Hai, buat apa terangkan kalau boleh tunjuk terus kan? Biar kebenaran jadi tour guide kamu. Jom! Inilah dia perpustakaan digital Siti Hasma.
Wah, siap ada kafe.
Perpustakaan ini dibuka 24 jam. Sorry.
Lepas tu, apa lagi kemudahan yang ada dekat sini?
Ada banyak lagi. Jom ikut kebenaran. Dah sampai pun ke studio green screen. Ada studio moken. Mak Mas 5G pun ada. Lepas kelas boleh ke gym untuk bersenam. Atau ke kolam renang bersaiz Olimpik untuk berendam. Jadi, adakah kamu berminat nak belajar di MMU? Wahai anak muda.
Ya, saya rasa MMU universiti yang terbaik untuk saya.
Kalau macam tu, isi borang ni dan daftar sekarang. Isi cepat.
Tapi, saya belum habis sekolah lagi.
Tak apalah. Yang penting, kamu ada cita-cita yang tinggi. Tata Titi Tutu.
Macam mana Cik Papa? Seronok tak hari pertama sebagai kaunselor MMU?
Memang seronok. Kebenaran tak sabar nak membimbing anak-anak muda lain untuk mencari kebenaran.
Baguslah. Sebab ada ramai lagi yang mahu kebimbingan Cik Papa ni.
Ramai lagi. Pilihan yang terbaik untuk masa depan kamu. Carilah kebenaran di MMU.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam perpaduan dan salam Malaysia Madani. Okey, syukur kita kepada Ilahi kerana dengan izinnya dapat kita bersua kali ini dalam satu seminar ilmiah bertajuk Teknik Menjawab SPM. Okey, hari ini adalah subjek terakhir untuk seminar ini iaitu subjek Matematik T. Okey, sebelum ini kita telah mengikuti ataupun mendengar tip daripada cikgu-cikgu pakar untuk subjek pengajian am, perakaunan, fizik, pengajian perniagaan dan juga ekonomi. Kepada pelajar-pelajar yang masih terlepas ataupun telah terlepas dengan program sebelum ini, mereka boleh ikuti di channel kami di channel YouTube dan juga Facebook iaitu Study at MMU. Okey, sebelum kita lanjutkan acara ini, saya ingin mengucapkan ucapan jutaan terima kasih kepada Jabatan Pendidikan Negeri Melaka dan juga Universiti Multimedia iaitu selaku penganjur bersama seminar ini. Dan tentulah tak lupa juga kepada pelajar-pelajar, guru-guru dan juga penonton-penonton di luar sana yang sedang menonton kami sama ada di channel YouTube ataupun di Facebook di Study at MMU. Okeylah pelajar. Saya harap pelajar-pelajar semua sihat di sana. Okey. Pelajar-pelajar semua, kalau yang masih belum subscribe channel kami, bolehlah subscribe. Ini bukan apa kerana di channel itu kami akan update info-info terkini dari Multimedia University untuk pengetahuan ataupun kebaikan pelajar di semua di luar sana juga. Okeylah. Okey, bersama saya Maizan Mahat sebagai moderator anda. Okey, sebelum saya memperkenalkan penceramah kita yang cerdik lagi bijaksana, saya nak minta izin sikit nak share slide MMU tentang berkaitan dengan MMU kepada pelajar ataupun penonton di luar sana supaya lebih mengenali apa itu MMU. Saya yakin mungkin ada pelajar-pelajar ataupun penonton sudah tahu apa itu MMU, tapi mungkin ada yang masih tertanya-tanya apa itu MMU. Jadi hari ini saya nak mengambil sedikit masa untuk saya share maklumat kepada pelajar dan penonton di luar sana apa itu MMU. Okey, izinkan saya share sekejap ya. Okey. Kalau ditengok dalam gambar ini, inilah suasana ataupun gambaran Multimedia Universiti dari sudut pandangan atas. Okey. Okey, untuk permulaan, MMU ni telah ditubuhkan pada tahun 1997 di atas nama Universiti Telkom. Dan kenapa nama dia Universiti Telekom? Okey, untuk pengetahuan penuntun ataupun adik-adik semua, okey, Universiti Multimedia ini adalah universiti swasta pertama di Malaysia dan ia merupakan salah satu universiti government link university ataupun kalau dalam bahasa Melayunya kita panggil universiti berkaitan ataupun milik kerajaan. Jadi maksudnya di sini apa-apa program yang MMU laksanakan tidak harus mestilah mengikuti ataupun tak boleh lari jauh dengan apa yang telah ditetapkan oleh kerajaan kepada universiti awam. Okey. Okey, di sini saya nak kongsi juga. Di MMU kita ada dua kampus iaitu kampus Melaka dan di Cyberjaya. Walaupun kita ada dua kampus, kedua-dua kampus ni mempunyai program yang berlainan, okey. Okey, dari segi pelajar pula, mungkin ada tengok kenapa ada gambar-gambar orang macam gini kan? Okey, sebenarnya kita bukan ada pelajar tempatan saja. Kita ada juga pelajar antarabangsa. Okey, lebih daripada 1,000 pelajar yang telah belajar di belajar di MMU sekarang dan juga mereka itu terdiri daripada negara-negara seperti Bangladesh, Egypt, Yaman, Indonesia, Saudi Arabia, Sudan, Pakistan, China, India dan Jordan. Kebanyakan mereka ini belajar di kampus Cyberjaya lah. Okey. Okey, seterusnya. Okey, di MMU kita ada 10 fakulti. Okey, setiap fakulti itu ada program tersendiri. Okey, dari segi domain ataupun bidang pengkhususan, di MMU ada 6 bidang pengkhususan. Okey, kita tengok kita ada engineering. Okey, di engineering ni kita ada Faculty of Engineering, FET dan juga Faculty of Engineering di Cyberjaya dan Melaka. Kita ada Faculty of Law. Okey, kepada adik-adik yang berminat nak jadi lawyer, okey, boleh join di MMU. Kita ada law program di kampus Melaka. Dan kepada yang bercita-cita nak jadi pakar ICT ke apa kan, okey, kita juga ada Fakulti Computer Science dan IT dan di program ni di-offer kepada dua-dua kampus. Kita ada offer di Cyberjaya dan juga di Melaka. Okey, kepada yang adik-adik yang ataupun pelajar-pelajar yang suka nak jadi seperti bidang kewartawanan, komunikasi kan. Okey, kita ada juga Fakulti Applied Communication yang ini di Cyberjaya. Okey, selain daripada itu, yang ini mesti yang minat kepada yang business, yang ada accountant, yang minat bidang pengurusan, okey, boleh join kami di Faculty of Business dan juga Faculty of Management. Okey, ini yang program yang ada di Fakulti Melaka dan juga Cyberjaya. Okey, dan tak lepas juga untuk yang terakhir ni kita ada Creative Multimedia. Jadi kepada adik-adik yang lebih suka cenderung kepada bidang-bidang yang kreatif ni, jangan lepaskan peluang untuk join kami. Kita ada Fakulti Creative Multimedia dan juga Fakulti Cinematic Art. Yang Fakulti Cinematic Art ni lebih kepada bidang perfilman lah. Kalau adik-adik bercita-cita nak jadi pengarah filem ke, nak jadi yang berkaitan dengan filem, penulis skrip ke apa ke, boleh join kami juga. Okey, mungkin adik dah ada cita-cita nak belajar di mana ataupun di MMU ke apa kan. Okey, sekarang ni bagaimana pula dari segi kewangan MMU boleh bantu? Okey, kita ada juga scholarship dan juga bantuan kewangan kami sediakan untuk pelajar-pelajar di MMU. Okey, apa scholarship yang dia ada? Okey, mari kita tengok. Di MMU sendiri, MMU ada menawarkan MMU President Scholarship. Yang ini kita beri tawaran kepada scholarship sepenuhnya kepada student dan juga kita ada juga MMU Merit Scholarship dan juga MMU Talent Scholarship. Apa tiga-tiga ni? Mari kita tengok. Okey, yang pertama, MMU President Scholarship. Kepada pelajar-pelajar yang dapat skor 9A ke atas, okey, kita akan beri dia 100% diskaun untuk tuition fees. Okey, yang ni tak termasuklah untuk dia punya hostel ke apa kan. Okey, begitu juga dengan pelajar STPM. Kalau dapat 4As, kita akan beri mereka 100% diskaun untuk tuition fees. Okey. Next. Tadi kan saya cakap pasal MMU Talent Scholarship kan. Okey, saya yakin mungkin ada pelajar-pelajar di luar sana yang mempunyai atau talent dalam bidang sukan dan pernah mewakili negara ke atau negeri kan. mereka juga layak untuk memohon scholarship yang kami tawarkan ini, MMU Talent Scholarship. Okey, yang ini adalah Yayasan Universiti Multimedia Scholarship. Okey, yang ini di bawah MMU sendiri. Salah satu scholarship yang ditawarkan adalah dinamakan Ibnu Haitam Scholarship. Okey, kalau kita tengok dekat situ, dia punya kelayakan dia untuk SPM dia perlukan 6A. Kalau STPM perlukan PNGK 3.0. Okey, apa yang ditawarkan? Dia memberi peluang kepada pelajar untuk mendapatkan tuition fees, living allowance dan juga bantuan buku. Mereka benda-benda tu semua akan diberi secara bantuan lah, maksudnya dalam bentuk scholarship kepada pelajar. Okey, selain daripada itu ada juga skim fisabilillah. Ini untuk Muslim B40 yang ingin melanjutkan pelajaran di MMU lah. Okey, apa yang ditawarkan adalah keseluruhan tuition fees dan juga trimester fees. Okey. Okey. Selain dari itu ada juga bantuan keuangan. Bantuan keuangan yang ini lebih kepada macam terbuka kepada semua pelajar, tak kira Muslim ataupun non-Muslim. Okey, walau bagaimanapun pelajar-pelajar haruslah memohon benda ini terlebih dahulu kepada Yayasan Universiti Multimedia. Okey. Tadi kan kita cakap MMU ni bawah Telekom. Okey, jadi Telekom sendiri pun ada Yayasan TM. Okey, apa kelayakan ataupun kelebihan yang ada di Yayasan TM? Okey, untuk yang pelajar-pelajar yang SPM diperlukan 6As. Okey, lepas tu untuk STPM dia 3.30 CGPA. Okey, apa yang diberi adalah tuition fees, what call that monthly allowance ataupun pembelajaran bulanan dan juga buku, bantuan buku dan juga apa-apa keperluan diperlukan lah. Okey. Dari segi applicable area of study tu kita tengok ada IT, kreatif multimedia, engineering dan management. So maksudnya dia boleh mohon kepada bidang-bidang tersebut lah. Okey, apa lagi yang kita boleh bantu untuk kewangan kepada pelajar di luar sana? Okey, kita ada juga di bawah JPA iaitu program ijazah dalam negara. Okey, pelajar boleh mohon. Okey, kepada yang Bumi Putra. Okey, kepada Bumi Putra mereka itu layak untuk mohon pinjaman daripada MARA iaitu dipanggil TESP. Okey, untuk mendapatkan TESP ini pelajar haruslah menjadi pelajar MMU dululah daripada untuk bidang degree. Okey, kelayakan dia haruslah mendapat CGPA 3.0 di peringkat asasi ataupun matrikulasi ataupun STPM dan setarafnya lah. Okey. Okey, katakan semua tak dapat kan, apa lagi solution yang kita boleh bantu di MMU? Okey, kita ada ni PTPTN. Okey, PTPTN ni dari segi level of study di MMU since daripada foundation, diploma, degree semua ada PTPTN. Maksudnya kalau yang nak masuk di MMU lepas SPM melalui foundation tak ada masalah, boleh mohon PTPTN di MMU. Maksudnya MMU ni PTPTN ada offer memberi kebenaran kepada MMU untuk tawarkan foundation ni PTPTN pada peringkat foundation lagi. Okey. Okey, itu sedikit tentang financial assistance di MMU. Okey, tadi kita dah tahu tentang MMU bila ditubuhkan, program apa, fakulti apa, financial assistance apa. Jadi kita tengok apakah yang telah MMU hasilkan. Okey. Ini adalah antara graduan MMU sejak ditubuhkan. Yang pertama ni adalah Amirah Hanis Zulkifli iaitu dia pelajar ni adalah Bachelor of Business Administration pada tahun 2007. Amirah ni adalah merupakan founder kepada Mimpi Kita dan juga merupakan is a local clothing brand lah. Kalau orang perempuan-perempuan mungkin tahulah siapa dia ni kan. Okey, apa lagi yang kita boleh share di sini? Kita juga ada, yang ini kalau adik-adik luar sana pasti dah tahu kan. Okey, siapakah ini? Muhammad Usama bin Zaid Yasin. Beliau adalah co-founder and managing director of Wow Animation. Yang tu yang Agent Ali kan. Dia founder dia. Usama ini adalah bekas pelajar MMU pada tahun 2006 dan mengambil program Bachelor of Multimedia dalam bidang filem dan animasi. Okey, siapa lagi? Kita ada TS Nur Muhammad Hilmi Nong Hazmi. Okey, bekas pelajar Bachelor of Telecommunication Engineering pada tahun 2003. Okey, dia TS Nur Muhammad Hilmi ni adalah founder kepada IX Telecommunication. Okey. Siapa lagi kita tengok? Ini yang paling ada ramai adik suka kan, tentang Mekamato. Okey, Muhammad Nizam Abdul Razak pula ni adalah juga pelajar MMU pada tahun 2005 dan beliau mengikuti program Bachelor of Multimedia dalam bidang filem dan animasi. Okey, hari ini Nizam Razak adalah founder kepada Animosta Studio Sdn Bhd yang menghasilkan filem Boy dan juga yang terbaru ni Mekamato yang mendapat keuntungan lebih daripada 33 juta dan dia jadi filem box office lah. Okey, siapa lagi yang kita tengok? Okey, Tan Ek Kiong adalah pelajar engineering pada tahun 2008. Dia sekarang ini menjadi founder kepada dan juga director kepada AMO Studio Sdn Bhd. Okey. Dan kita tak lupa juga kepada pelajar yang ini adalah Dr. Behrang Hani atau Hizkar. Beliau adalah pelajar Bachelor of Multimedia Technology Management under Multimedia Human Computer Interaction pada tahun 2008. Okey, sekarang ini dia mempunyai syarikat sendiri, dia dipanggil Camran Digital Group. Okey. Dan yang last kali kita ada Encik Nevin Sinatambi. Okey, beliau ini adalah pelajar engineering pada tahun 2006 bermulanya. Okey, kini beliau bertugas sebagai Head Department di Digital Agriculture dan Drone Technology Ecosystem, iaitu Industry Development Division di Malaysia Digital Economic Corporation MDEC. Okey, ini adalah antara alumni ataupun graduan MMU yang telah berjaya di luar sana. Sebenarnya ada banyak lagi tapi kami cuma ambil yang berapa saja. Okey, kalau di MMU kita panggil permata dunia itu adalah kita punya pelajar lah, kita panggil permata dunia. Okey, sekiranya ada apa-apa persoalan ataupun pertanyaan, okey, pelajar-pelajar bolehlah menghubungi kami di email ataupun di website ataupun boleh follow kita punya Study at MMU Facebook, kita ada Instagram dan juga yang baru kita ada channel YouTube Study at MMU. Okey, itulah adalah serba sedikit tentang MMU. Okey. Jadi kita teruskan acara kita. Okey. Okey, baiklah. Sebelum kita mendengar tip dan nasihat daripada penceramah kita, orang kata tak kenal maka kita tak cinta, betul tak? Okey, sebelum itu izinkan saya memberitahu ataupun menceritakan sedikit kepada pelajar atau penonton di luar sana, siapakah penceramah kita ini? Okey, beliau yang saya masukkan ini adalah Cikgu CHU MAW SHAN. Okey, cikgu ini merupakan guru jurulatih utama Matematik T Negeri Kedah sejak 2013. Beliau berpengalaman mengajar Matematik T tingkatan 6 ni selama 25 tahun. Saya rasa adik-adik pun belum lahir waktu tu. Okey, kini berkhidmat di College University Kulim. Okey, saya yakin dengan pengalaman yang sedia ada pasti banyak tip dan nasihat akan diberikan oleh beliau lah sebentar lagi. Okey, saya harap pelajar-pelajar semua sudah bersedia dengan kalkulator ke kertas ke apa kan? Okey, sebelum kita mulakan. Okey, sebagai pembuka bicara saya nak pantun sedikit lah. Okey, pergi berkelah membawa ketupat, bawa bersama tikar dan roti. Hanya tunggu tip dan nasihat. Kami pelajar tak sabar menanti. Okeylah, tanpa membuang masa, saya menjemput Cikgu CHU MAW SHAN iaitu guru Matematik T untuk meneruskan seminar ini. Okey, dipersilakan Cikgu.
Ya, selamat petang Encik Maizan.
Ya, selamat petang Cikgu. Apa khabar Cikgu?
Ya, selamat petang juga kepada semua pelajar dan cikgu yang mengikuti program ini. Jadi saya juga mengucapkan ribuan terima kasih kepada pihak MMU dan JPN MELAKA kerana memberi peluang kepada saya untuk berkongsi apa yang saya tahu, apa yang saya belajar supaya boleh memanfaatkan semua pelajar yang akan mengambil peperiksaan STPM bagi mata pelajaran Matematik T. Jadi tanpa buang masa, allow saya to present my word. Okay, bye. So the teachers and students, hopefully you can see my screen that I have shared. Okay. So in this 2 hours slot, I will try to touch in these few things. First, we have a look at the overview of the exam papers regarding the instruction and also regarding the formula provided. We get some insight from here. Secondly, I will try to highlight each of the chapters that is related to the question that I want to discuss. And then we will look at the essential working that we should present when we answer the exam questions so that we can get the marks that we deserve. And also the common mistakes that we should avoid in answering the exam questions, and what you should do and what you shouldn't do, and how is a proper way to give the correct answer. This is roughly what we are going to discuss in this slot. Okay. I invite all of you to share your thoughts or opinion or comments throughout this session. So I will try to look at the chat. If any question, you can ask me. So I try to answer. Especially here also, we have a lot of the experienced teacher here. They also can help. Okay, first, let's have a look at this, the front page of the exam papers. So I think you have been go through. I just want you to have a look at this formula list. If you look at this formula list, what is provided? So you are provided with this formula to differentiate the art sign, art tangent, and art cos. This is exactly the formula list provided in the 2022 ulangan. So the next is this product rule, and then the quotient rule of the differentiation. Next, you have the integration. The first one is the integration by recognition. Then the second one is the integration by parts. Next, you are provided with the standard series of this Maclaurin series. All right, you see only the loan, the interval of convergence is provided here, isn't it? The interval convergence is from x greater than -1 and less than or equals to 1. How about the others? It's not provided. It's not stated It's not stated here. So you should understand that it is for all values of x, which will be used for all values of x. So as the sine and the cos. So if you look at the next one, Newton-Raphson method, the formula is provided, and the trapezium rule. All right. I may not have enough time to go through this. I suggest that you go to my previous video, YouTube video, in which when I talk about the answering technique for the paper 1, ulangan 1, I have discussed a little bit about how to write the answer, especially what is the difference between exact answer and the round of answers, and what if the instruction is saying show that, prove that, then what should be the proper solution or proper working that we should show. So the hence and deduce, calculate, find, determine, and solve. So the give, state, write down what makes a difference with all these keywords in the exam questions, and explain and justify. I may not have time to go through here, so I suggest that you can refer to my previous video with this title, Success STPM Matematik T. All right, let us go to the first chapter. First chapter. First chapter, this regarding the limits and continuity. First, we need to have this idea, understanding of this idea in the indeterminate form. So roughly here have the 6 types of indeterminate form, in which when we sum, we get the situation where 0 over 0, infinity over infinity, infinity minus infinity, and 0 times infinity, 1 power infinity, and 0 power 0. As you can see, I have highlighted the 3 cases. 0 over 0, infinity over infinity, infinity minus infinity. These 3 cases have been come out in our exam papers. Do you realize it? I think the infinity minus infinity came up once, but the rest are 0 times infinity, 1 power infinity, 0 power 0. So far, haven't been asked. All right. Later, I will have a little bit discuss on these 3. Before that, let us look at this. Basically, the method that we use to evaluate limit. So if the limit when x tends to a, normally we will sub, especially for this in the rational form. In this rational form, you sub the a into the function f and then also to the function g. If the substitution finally gives a 0 over 0, normally we say we simplify by factorization or multiply by its conjugate. If this, after substitution we get infinity over infinity, we will use division using the highest power of x. And then for these two, 0 over 0, infinity over infinity, normally we can use L'Hopital's rule, not hospital. L'Hopital's rule, in which we try to differentiate the f at the top and the g at the bottom separately, not treat it as using the what we say the quotient rule. We differentiate it separately, and then we sub. If we still get the same indeterminate form, we will continue to differentiate it until the substitution can be done, in which without the indeterminate form. If we look at these 6 cases, overall, finally we should come to these 2. These four normally if exists, we'll try to make it become these 2 forms. So we can apply the method as I mentioned here, by whether we use factorization, division, and L'Hopital rule. But not all the cases can be factorized. Not all the cases can be division. So sometimes we have to resort to this L'Hopital's rule. Let's have a look at this L'Hopital rules. So as you can see, this is the question in 2015. Evaluate this one when x tends to 2. So when you sub, you get at the top, you get 0. And you sub at the bottom, you also get 0. So this is the case 0 over 0. So indeterminate form, 0 over 0. So if we got 0 over 0, normally we say we try to use factorization or conjugate, multiply with conjugate. So in this case, we can, but this x cubed minus 8, this x cubed minus 8, we need to carry out the theorem factor, in fact, to get the first factor x minus 2. We need the theorem factor. theorem factor to get the factor x minus 2. Then we may carry out the long division or using the equal polynomial to get this quadratic expression x squared plus 2x plus 4. Normally, we don't try to expand the other side, which is the other side at the top here. 6x minus 2 will remain as 6 multiply the bracket x minus 2, because you can see at here you are able to simplify it. Simplify it to leave it in this simplest form, then you can sub. But if we use the L'Hopital's rule, things become so simple. So simple. You see this at the top here, 6 bracket x minus 2. When you differentiate, you get 6. At the bottom here, when you differentiate, you get 3x squared. So directly after that, you can sub. You get the half. Very straightforward. L'Hopital rules, this is allowed to be used during the exam. Okay, let us look at another 3 cases here. These key cases. Okay, here I will try to have a simple discussion on this another 3. This one, the infinity minus infinity, later I will discuss with a question, a partial question. Right now I have a little bit discussion on this 3 determinate form. So you see the first case, find the limit for this function x ln x when x tends to 0. When you sub, you get 0. X is 0. Ln x, you sub, you get actually you get negative infinity, because when the x tends to 0, the y will goes to negative infinity without bound. So it's a case of 0 times infinity, or here is specifically negative infinity. So how we should deal with this type of situation? Actually, I go through the syllabus. It never say this won't come up, because it's not mentioned clearly which are the cases that will be asked. Sometimes exam paper will surprise us. For example, that year, 2015, suddenly come up this infinity minus infinity. Okay, we just learn a little bit skill, then we can handle it easily. So as I said, normally these 4 cases, we can try to rewrite such that it is in these 2 forms, 0/0, infinity over infinity. So if we manipulate a little bit, this x, we just put it as divided by 1/x. Then we get the case in which it is infinity over infinity, which is an indeterminate form. Then we can apply the here actually you need L'Hopital's rule actually. You cannot factorize because nothing to factorize. You cannot use conjugate because no conjugate, and you also cannot use the division. So here the L'Hopital rules is only the way we can use. So you differentiate at the top, you get ln x, you get 1/x. So when you differentiate 1/x, you get negative 1/x squared. So you simplify, you get negative x. Then you sub. Sorry, I think I put it wrongly. 0. Okay, 0. 0. So when you sub, you get 0. You get 0. All right. Let us look at another case. This I think we look at this case first. This case. This limit for the x to the power of x. When you sub, you will get definitely is 0 over 0. Over 0. So as I said, we will try to change the form into the first two cases, indeterminate form. So what we can do is we make use of the exponential function, e ln x power x. Then we are able to express as e x ln x. E x ln x. All right. So we already just make use of the previous case, limit for the x ln x where x tends to 0. Actually, if this case itself, you have to go through this step. You have to go through this step. So since we already got the figure, which is 0, then it means that the limit is all is depend on this part, x ln x when x tends to 0, which is 0. So you get e power 0 is 1. Okay. So this is basically how we deal with this type of indeterminate form. Okay, next. Existence of limit at x equal to a. So when we want to determine whether limit exists when at x equal to a, normally we have to check a limit tends to a from the left. This one, the left. Limit tends to a from the right hand side. Whether it define, if both define, is it both equal to L? Then only we can conclude that limit exists. So if you look at this partial question, you see this partial question. 2022 ulangan. Okay. So you have 3 pieces here. So when we want to determine the x tend to 0, so first we check the direction from the left to the 0. We use the first piece, 2 plus 3 ex. So when we sub the 0, we get 2 plus 3 e power 0, we get 5. Then when we look at the right direction, tends to 0 from the right hand side, which is second piece will be used for x tend to 0 from the right. So we use 2 plus 1 over x here. But when you sub, you get 2 plus infinity, which is infinity, or we say undefined. So actually, we can immediately conclude that limit does not exist at x equal to 0. One question for you: do we need to come to this stage to compare? Do we need to compare here? Actually, no need. Once you found that one of the conditions does not fulfill, then we can immediately conclude that limit when x tends to 0 does not exist at all, because from the right it is undefined. So no need to go to the step that we compare both. We only compare when you got the left limit defined, right hand limit defined. Then you compare whether they are the same. Now the situation here is from the right there is undefined. So immediately it will be not exist. Okay. Then another popular question is on this continuity of a function at a point. So it must have 3 conditions. Continuous, if all this happen, all must happen. Limit when x tends to a exists, fa is defined, and then the above 2 must be the same. If one of these does not happen, then we immediately can conclude that it's discontinuous. One of these does not happen. This type of question has been asked. For this question, I think you should have remember this one. a function f is discontinuous at a for 3 different situations. State the situation. These are the 3 situations you should state when you answer this question. A limit when x tends to a does not exist. Fa is undefined. If both these two happen, you compare. Compare does not equal. Okay, so these are the limit. Okay, another one issue or that we may encounter is with the direction limit involving modulus. For example, this one. Do you see the function here? At the bottom here got modulus. So we have to choose a correct piece before we consider the limit. So I put it like this. Hey, sorry. My slide distorted. Okay. So for this modulus function, actually you need to figure out what are the 2 pieces here. So it will remain as 2 minus x if 2 minus x itself is positive or 0. If 2 minus x is negative, this means if 2 minus x is negative, then we will put the negative in front here so that negative times negative become positive, because modulus always want the absolute value, which must be positive. So that's why for this interval, finally we get x greater than 2. This interval, after we add the negative in front, it becomes x minus 2. So it should have 2 pieces. Right now, we go back to here. It says that x tends to 2 from the right-hand side. From the right-hand side, which piece? It must be using this x greater than 2. Then we take this piece, x minus 2, to be used here. So then we can simplify to get x plus 2, and then we sub get x y 2 plus 2 equal to 4. Okay. All right. If you have any question, you may ask in the chat. I will have a look once a while. All right. Next one, we look at this past year question. Same. This one same lah. Okay. I don't want to repeat. I just want to have a look at this B. So as I said just now, this case, when you sub the x, which is infinity, into the function, you get the indeterminate form, which is infinity minus infinity. So here what we should do, we multiply the conjugate. After we multiply the conjugate, which is square root plus another term here, x power 3, at the top and at the bottom. Then you expand it, you simplify it, you get this one. When you get 12x cubed divided by square root of this expression plus x cubed, actually you already changed the function to this form, infinity over infinity. So from the infinity minus infinity, now you change to infinity over infinity, even though still indeterminate form, but this is the indeterminate form that we can handle. We can handle using what we say, using the divide with the highest power of x here. Here we divided by x cubed. After we divided by x cubed, so you get this 12 over square root of 1 plus 12 over x cubed plus 1. This case, especially this type of cases, the substitution, please try to show. Try to show the substitution, especially this part. This part. Actually, this part is a method there, in which 12 over infinity, we get the 0. So we must indicate here the 0. Normally, it's a must shown step here. A must shown step here. If you are not very sure which step you must show, which step you do not need to show for substitution, I suggest that we sub all. We sub all. At least we try to avoid marks being deducted. Oh, time go very fast. Okay, we go to the another chapter 2 now. Chapter 2. Chapter 2, first of all, students, you must try to memorize all these standard function with its derivative. Okay, because you will not be given. You cannot miss one of it in case it come out. So you must get given tangent x, you must immediately know it is second square. Okay, so here you see the 12, 13, and the 14. This one you can make use of the formula given in the formula list in the question paper. Formula list, kan? Still remember just now? Okay, this one is provided. The formula list is provided. Okay, art sine, art cos, art tangent. But you must able to show how to prove it. Able to prove it. Okay, I'm not going to spend times here. Okay. Another one is the general power rule as a special case of chain rule. So this is just my simple guidance for general power function. For example, if you have y equal to bracket power 5, if the bracket inside bracket is 3x minus 2, so you can just follow this one. First, you carry out this step, 5, 3x minus 2 power 4. Okay, and then you differentiate the function inside the bracket, then you get the 3. And then you go further and simplify everything, 15 times bracket. So in case you get given a y equal to ln sine 3x plus pi. Here, I always try to suggest that we consider it as having layer by layer. So here, 3 layers. So the first layer is the ln a function. So ln of a function, you get 1 over of the function, isn't it? Ln fx. When you differentiate, you get 1 over fx, isn't it? So the first layer is the ln. So you get 1 over sine 3x plus pi. Okay. The second layer is the sine. You differentiate sine, you should get cos. So it's a chain, it's a chain multiply. You should get cos 3x plus pi. Okay, lastly, the inner layer is this function that inside the sine, which is 3x plus pi. So you differentiate, you get 3. Okay, so you finally get the 3 cotangent, cotangent 3x plus pi. Okay, so this is a simple guideline. When we had this, actually it's called composite function, or we say the general power rule. Okay, another thing I will try to highlight here is that the algorithm or the steps that we use to determine the nature of a stationary points and verify a point of inflation. Okay, if the question asks us to look for the stationary points, then immediately you should know you use dy dx equal to 0. Work from here to get the values of x. The values of x you obtain, normally it will be asked to determine the nature. So to determine the nature, we have 2 options. One is using the neighborhood test. Another one is using the second derivative. I always prefer or suggest students to use the neighborhood test, which will be much easier, even though a little bit tedious. Rather than use d2y, you may make mistake. You may make mistake, especially for those who are weak in doing the derivative. So look at this neighborhood test. So when x is a, dy dx is 0. So for the values that is less than a, and then the values are greater than a, you test. You just test the values that's very near to a lah. For example, if let's say a is if 3/4, here a. So normally how? I suggest you simply you just press the calculator 3/4 minus 0.1. You get a very near a value that's near to the a. Here you press the calculator, you sub 3/4 plus 0.1, isn't it? You sub into here. Okay. Now let's say if in case you get this table minus 0 positive, minus 0 positive, it means that you can conclude it is a minimum point. If you get positive, 0 negative, so you can conclude that is a maximum point. Just now is a minimum point, maximum point. If you get at the both side is the same sign, positive, positive, or negative, negative, then you can conclude that is an inflation point. All right. In case you use d to y, okay, if you get d to y, you sub, you get positive, you can conclude it's a minimum point. If d to y get negative, you can conclude it's a maximum point. But d to y equals 0. Now, can you conclude that it's an inflation point? No, no. Not yet. Okay. Then you have to go to this step now. Follow the arrow here. You go to this step. Go to this step in which you have to carry out the neighborhood test, which involve the second derivative, or you use the d3y. That is the algorithm that we have to follow. So this is the situation where d to y from the this stationary point we test, we get 0. So you cannot conclude it is a inflation point. You still need to verify with this second derivative neighborhood test or using the d3y. Okay. Now, if the question say find inflation point, then we use d to y equal to 0. D to y equal to 0. Okay. After you obtain your values of x, then you carry out either you use the neighborhood test or you use d3y. If for this one first, d3y shouldn't be 0, then we can conclude it's the point of inflation. But in case d3y is 0, but this one so far never happened in our exam questions. So far never happened. If happened, d3y gives 0, you cannot make any conclusion. You still have to go back to this table, neighborhood test, to check whether there is a concavity changes. Okay. So this is algorithm that I built up to help students to determine the stationary point and their nature, and also the inflation point. For graph sketching, normally, what are the things that you have to show in a graph? First must be the intercepts, the x-intercept, the y-intercept, T, the turning points. Here I didn't write the point of inflation. In case the questions say 5-point inflation and then hence sketch a graph, then you use it. If not, we just look for the turning points. We will ignore the point of inflation. Unless the students, the question asks for it. Okay. Third, we will try to look for the asymptote. Especially when the function is a rational function. So to look for the vertical asymptote, we consider when as y tends to positive or negative infinity, gx tends to 0. When gx tends to 0, from here we will get the vertical asymptote. For the horizontal asymptote, consider the limit of y when x tends to positive or negative infinity. Okay, then we see the limit of y. That will be the horizontal asymptote. Also, we are trying to check the infinity, which is the behavior of the graph when x tends to positive or negative infinity. Whether when the s become larger and larger, the graph increase with no bounds or whatever, you must try to figure out. Then the shape of a curve must consistent with the graph concavity. What I mean is, if you found that, let's say the x greater than 3 is concave upward, let's say here is 3. You must show the graph concave upward. If here is 3, your graph is like that, then you are wrong. You are wrong. You will lose the marks. So the concavity must be shown clearly, even though it looks the same for many students. They don't bother as long as they get this, roughly the shape. But actually, exam it is very particular. If you know x greater than 3 concave upward, then the shape of the graph must be consistent to what you found. Okay, now we look at the few of the past year question. I can go faster. Okay, numbers. Oh, sorry, have a look at this student. So how to do if x power of 2 have modulus? As x if power 2, it itself must be positive. X power 2 is positive. This Aiman Ganteng. You mean finding the limit? If x of power of 2 has modulus. So if x already power 2, whether it have modulus or no modulus, it makes no difference. Because power 2 will be at least 0 or positive. Okay, look at this chapter 2, question 7, which is 2021 ulangan. Here a curve has equation y equal to 1 plus x squared times e power 5 minus 3x. Find the coordinate of the stationary points and hence determine their nature. Okay, and then find the coordinate of point inflation correct to 2 decimal places. Here you must follow the instruction. Instruction 2 decimal places. Always be careful here. And then sketch the graph. So you see this sketch the graph. You must show your point inflation because you have already figured out this point. Your graph must have a point inflation and all the stationary point. Okay. So that to find the stationary point, you use the dy dx. Okay. When dy dx is equal to 0, here be careful. Because the dy dx have two expression here, e to the power of 5 minus 3x. Here we have to justify why only is 2x minus 3x squared equal to 0 by saying this function will not be 0. It is always positive actually. Or you can say it's always positive, but most importantly, it's not equal to 0. It won't be 0 because we are concerned about whether it's 0 or not 0. Okay, so we only consider this equal to 0. And then this is what we say justification you must make in the exam. Okay, you got two values. Here I carry out the neighborhood test. Then I get 0, negative, 0, positive. So it is a minimum point, a local minimum point. Here is a positive, 0, negative. Here is a local maximum point. Some will ask, does it must to write local or just write minimum point? By right, it is a local minimum point. By right. But normally, so far, they don't very specific on this. And then when you see, when find the stationary point, this conclusion must be made. You must take this one. The stationary point. A conclusion must make. You must answer the question. Remember, each time you do the question, you must check whether you answer the question or not. After you getting the result is the result answer the question. So you must take. Okay, this one, after you carry out the neighborhood test, you do your conclusion. Okay, now next, you do your D2Y to find the inflation point. Same as just now, when you get this two expression, the product of two expression, the first one, e to the power of 5 minus the 2x is not 0, then only the 9x squared minus 12x plus 2 is 0. Okay, here cannot be factorized, so you apply the quadratic formula. Don't just press calculator. Show your steps. How you sub into the quadratic formula. Pressing calculator directly get the figure, but without this method, you might lose your marks. Okay, might lose your mark. So answer as instructed must be in 2 decimal places. 2 decimal places. Not yet can conclude it is a point of inflation. You have to verify it, as I said. Then you use the neighborhood test with second derivative here. So if you check, here is concave downward, here concave outward. So sure it is a point of inflation. So as the second one, at the left, concave up, at the right, concave downward. Then only you say the point of inflation are these two. Conclusion should be made. Okay, based on what we have found, then we sketch a curve. Whatever you have found, try to display it in a graph. And then adding all the important feature of the graph that is a mass, as I said just now. What I said is just now. The x-intercept, y-intercept. If any asymptote exists, you have to figure out. Cannot just based on the points you obtain. The important figures of the graph also must be shown. So this thing, correct shape and display correct concavity. You see just now, for example, 1.14 at this inflation point, 1.14, you see, okay, everybody have a look here, 1.14 at this point. To the left, it is concave downward. So concave downward, this shape is concave downward. To the right-hand side, it is concave upward. So this concavity must be displayed in the graph. So as the other one, 0.2 at this point. Just now you have already checked the left-hand side, concave upward. So your graph must show the concavity upward, concave upward. To its right-hand side, you found that concave downward. So you should display concave downward in your graph. Here, you need to figure out the asymptote by considering an x tends to infinity. This one we have to carry out this step. So this is how a graph is produced. It takes a lot of effort actually. Okay. Any question? Okay, let us move on. Chapter 3. Chapter 3. Chapter 3, when especially this one, when we want to do integration. First, you must recognize what are all the standard integral. So, especially you see these three. These three, even though it's not provided, but you can make use of the formula list in the front. In the formula list, you are given this one, isn't it? Differentiate the art sign equals to this one. I mean in the formula list. So the reverse is integration of this one, you get art sign. So you can, if you forgot, you can refer to it. How to do the integration of this trigonometry, inverse trigonometry. All right, here I have one guide for you to make the thing simple when it comes to integration. look at this one in general. If I integrate a function f, I get this big F. Then, if the object, instead of x, it is ax plus b, ex plus b, still, okay, after integration, you get the big F. So here is the linear form. You see the ax plus b. This is ax plus b. It's a linear object here. Remember, just divide by a. You get the correct integration. So for example, integration of 1 over 3 minus 2x. This one we refer to this one. This one. Instead of x, here is now is expression ax plus b. Ax plus b, which is 3 minus 2x. So after when you integrate, you get ln. Ln of the linear function here, 3 minus 2x. Inside this linear function, it is a negative 2. Then you just divide it by negative 2. You get the correct integration. You can apply to all the standard integral here. Even though I quote another one. Let's say this one. This one. This one is related to this one, the art sign. I make it bigger so you can see the relation. So try to delete these two. Delete these two. So if the standard one is integrate 1 over 1 minus x squared, you get art sign x. Now, instead of x, you see, instead of x, it is ax plus b here, isn't it? Ax plus b. So as I said, the integration get art sign. Okay, you just give art sign. Okay, art sign. Then inside this art sign, you got the linear function ax plus b. The coefficient of x is a. You just divide it by a. You will get the correct one. You get the correct one. Okay. Later I will discuss one question here. Past question. Next. Other than standard integral, you must recognize all these standard integral. If standard integral is none of the case of the standard integral, normally we'll try to consider whether it can be using by recognition. Whether is this pattern happen, these three pattern, if we recognize it, we can directly apply the formula. Okay. If the integrand is an trigonometry, which is a cos square, tangent square, sine square, or even cos power 4, even, the power is even, cos power 4. We still can integrate by using the trigonometry by changing this cos to this one, the cos, by changing the cos square x into cos 2x. In the form of cos 2x are the form that I can integrate because it belongs to one of the standard integral there. So the purpose of doing this, changing the form, is to get the standard form that we can integrate. So tangent square, using the trigonometry, 1 plus tangent square equal to secant square x. You're able to write as a secant square x minus 1, which is this form, this one, you can integrate. So in the integrate secant square, you get tangent. Tangent. All right, so as if you have a 2 sine square, 2 sine square, you can use a cos 2x equal to 1 minus 2 sine square x to change into the cos 2x. In case we have the rational function, especially like this one, then we have to carry out the partial fraction or using the long division. Also, you may try to memorize these two. This one can apply as a formula. Okay. Let us look at the way we deal. For example, here we have the integration of dx divided by 4x squared minus 25. Okay, the method one is I'm trying to change into this form. This form you see. the coefficient of x squared is 4. So I bring out the 4. So here must be 25 by divided by 4. So by doing so, now this a square at here is 5 over 2. A is 5 over 2 here. It's 5 over 2. So follow the formula. Okay, follow the formula now. It must be 1 over 2a. This is the a. 1 over 2a is here. Okay, this 4 is 1 over 4 is here lah. 1 over 4. Okay, applying the formula is 1 over 2a. Okay, then just follow the formula alone. X minus a divided by x plus a. Okay, plus c. Second method is try to use this one. Try to use this one. This x, not necessarily is a x. Any linear expression of x. So this 4x squared, I change to 2x squared. So this is the linear form, 2x. So as I said, follow the formula is 1 over 2a, isn't it? The a is 5, ma? The a is 5. 1 over 2a. Okay, then you integrate as usual, 2x minus 5. Okay, inside here got 2, ma? Got 2. So I say divided by 2. That's why this the 2 come divided by 2. Divided by 2. One of the 2 is appear in the formula itself. One of the 2. Another 2 is from the 2x. Yeah, the 2. Okay. So these are the technique that I can suggest to you. Okay. Now look at this another one. When we come to integration by substitution, this case have been asked in the past question. In which we have odd power of sine x, then we use a substitution u equal to cos x. For example, sine cube. Here we have the mix here, got the cos square and then sine. So sine is even, the power is even. So you use cos. Okay. If the odd power happen to the cos, for example, cos power 5. Cos power 5. Here power 2, definitely we use u equal to sine x. If both is odd, then either one can. Okay, so in case you have this term in your integrand, square root of a square minus x square, you can use this substitution, x equal to a sine theta. Or this happen in your integrand, a square plus x square, then we use this substitution, x equals a tangent theta. I suggest that we ignore this. I found that some of the books introduce these cases. I what you say? If you have no time, if you have no time to study, you just ignore these two. Okay. This is just my opinion. And then integration by parts. Hopefully you know the priority to choose the function as u, in which we use this acronym I late. The I will be the first inverse trigo function, will be the first priority to choose as u. So follow the sequence here. So you see the exponential function will be the last to be chosen as the u. Okay, look at a few examples here. Look at this. This is the reason one. 2022 ulangan question 3. Express this one in the vertex form. Okay, after you get the vertex form, here you have to carry out completing the square to get the vertex form. Then hence mean make use of what you have obtained. So this 5 minus 2x minus x squared expressed at vertex form. So when it is in this form, immediately you can relate it to the art sign, isn't it? The art sign. You want to use the integration of the art sign. This one. Integration of this this one, 1 over 1 minus x squared equals to at sign negative x. So here got 6. You try to take out the 6 here. But when you take out the 6 here, you factorize the 6 here. Here, non-6 one. But when you square it, you should put the square root of 6. Because you later, when you power it, you get 6. Then 6 times it over 6, go back to the original one. Okay. After you doing so, you can see it's in the form of the standard integration. This form, 1 minus x squared. So you see, this is 1 minus a bracket square. So inside the bracket is a linear factor. It's a linear factor. The coefficient of x is what? The coefficient of x is 1 over 36. 1 over 36. 1 over 36, as I said, you can directly apply this formula now. You see this arrow? Okay, I discussed this first. This arrow. Okay, this arrow. Okay, this one over 36. This one is this one. This one is this one. Okay, 1 over 36. Then follow the standard integral. You get at sign. So here get at sign x plus 1 divided by 36. Then I say the coefficient is 1 over 66. So you bahagi divided by 1 over 66. It means that you multiply 36 here. Square root of 6 here. So that's why you can get this form. Or you carry out the substitution. Here, inside this square, the bracket square here, you sub it as u. Then you use the du dx equal to 1 over 36. Okay, then you change everything into u, in terms of u. You've got the limit also change, isn't it? There are 3 things to change. In fact, normally, the dx change to du, all the terms x change to u, including the upper and the lower limit, all change to u. But here, no limit. Remember, there are 3 things normally. But here got 2 only without the limit. This is not the definite integral. Okay. So from here, definitely you see the 1 minus u square. So at sign u plus c. Then you sub back your u. Okay, and another method, substitution method. As I said, when you can see this expression, a square minus x square, you can use this substitution, x equal to a sine theta. So this is obviously the a is square root of 6. Square root of 6 power 2 is 6. So minus x plus 1 square. So the x here not necessarily must be x. As I said, it can be a linear factor in terms of x plus 1. Okay, so you use a substitution. The x here, as I said, now is x plus 1. So you put as x plus 1. This x, x plus 1. A sine theta. A is 36. A square. So the a here is 6 sine theta. Then you differentiate dx d theta. Okay, now you go back here. You sub to eliminate all the x, including the dx. Okay, you see here you are able to simplify everything until you get cos theta at the bottom. Then you divide it, you get 1. Then you integrate, you get theta plus c. Then go back to your theta, which is at sign. Okay, so there are 3 methods actually we can use to solve this question. Okay, let us go to the chapter 4. Chapter 4. Chapter 4, solving differential equation. So we have 2 types only, isn't it? Basically, 2 skill. One is a differential equation with separate variables, Another one is first order linear differential equation. Others form, we need substitution. We need a substitution to change to either this form or this form. So only two skill lah actually, only two skill. Okay, for the first order linear differential equation, there are fixed steps to be followed. Dia ada langkah-langkah yang tetap yang perlu kamu ikut dan tunjuk. Okay, for example here you are given the y prime plus py equal to q. So you identify your p to find the integrating factor f. After you find your integrating f, you multiply your f, isn't it? Ini langkah yang wajib, is a compulsory step to show. You multiply the f to the both side of the equation. Okay, after you multiply, here I explain, but I don't think I have time to go very detailed because I found that I'm short of time now. Okay, this fp itself is a f prime. So if it looks like it's a reverse of the product rule, so we go back to the dfy. After you multiply by f, immediately you can show this one already. You don't bother what is happening. You multiply saja, then you can write as differentiate fy equal to fq. Forget here also multiply by f. Then you integrate both sides. Okay, we look at one example here. Okay, before that, I just briefly go through when it comes to modeling a problem as a differential equation. If you see the situation is increased, a particle falls from the rest in medium, causes the velocity v to increase at the rate proportional to its velocity. Increase, the dvt must be positive. If got decay, it must be negative. Decay must be negative. Okay, I have to skip. I have to manage my time. I will go to this one, past year question. Look at this one. Show that the substitution y equal to ux transform the differential equation into the differential equation. Okay, we look at the first part first. So you are using this substitution y equal to ux. So you differentiate the y, this side is u, and then differentiate the x, get 1, u times 1 plus the x, differentiate the u, you get du dx. Okay, so you sub everything to eliminate the y. The purpose is to eliminate the y. So all the y and dy dx is substituted. So you are changed the differential equation in terms of u and x only. U and x. So it's in the form that we can solve. It's in the form of differential equation that we can solve. So obviously, when you look at this one, especially at this stage, it already very obvious it is a separable variables form. Separable variables form. Okay. Then definitely we have to use the separate variables. One thing here you have to be aware is this part. Attempt to find C. Don't just write the C. Don't just write the C. You must show the word attempt to find the C. Sometimes it got 2 marks. One is for the method and one is for the values of C. So in case you just write the C, we worry you might lose the marks. Or if your C is wrong, you cannot get the method marks. Then nothing you can get. So if you show the working, at least if your C is wrong, you get the method marks. Okay. Sometimes even look very simple. Directly you can see, you get the C. But in the examination, we advise you to show the method. To show the method. Okay, now come to the answer. Come to the answer. If you look at the answer here, no matter how I do, I cannot able to put y explicitly in terms of x, because even though I get this form, I still have this y here. So it is a case that y cannot be explicitly expressed in terms of x. So that's why in terms of the answer, it can be either this form or this form or this form. All can. Doesn't matter. But in case if y can be expressed explicitly in terms of x, we should work towards it. We should work towards it. All right, next one. Okay, here I just want to highlight the parts that we use the integrating factor. Okay, this is question number 8. I think you have already worked out. Now we look at this part only. A, I just skip it. We come to B. Come to B. First of all, always put it as a habit. Whenever you read the question, you just try to summarize what the given as a table. Because here is about the time, the t, and the variable x. So you are given that when t is 0, x is 100, and then one more, t is 1, x is 80. Sometimes the t is 0, it doesn't mention, it just said initially, kan? Initially. So initially means t is 0. So try to put it as a table form. Okay, normally the first values, it will enable you to find the c, the constant, and then the other one is to find the k. Okay, but not necessarily it's like that. Not necessarily it's like that. Okay, here I just want to have a look at this part. Okay. Okay, now we look at this one. dx dt plus x equal to negative kt. So obviously this is the first order differential equation. Then the integrating factor f equal to e integrate the 1x only. So the p is 1. So you get e to the power of t. Now the f is e power t. E power t. Your work next is just show this step only. Multiply e power t. Just multiply. Multiply e power t to all the terms here. To the equation. Then immediately you can just memorize a hafal saja lah. Next step is write in this form. Differentiate fx here. Fx here. Differentiate the fx here. At the left hand side. The left hand side must be differentiate fx with respect to t. Ini kena hafal. Ini kena hafal. Kalau kamu tak faham, hafal sajalah. Nah, di sini. Okay. So the rest is just integration by parts here. I just skip it. Okay, let us go to the chapter 5. Chapter 5. Sorry, I have to go a little bit faster. Chapter 5. Chapter 5, Maclaurin series. This is the Maclaurin theorem, the formula. Okay. Regarding the use of this formula, let us look at this example. For example, I calculate, and then I calculate the first derivative, second, third, and fourth. Okay, I sub zero into each of these. All right. After I sub, you see this one, the third derivative sub 0 gives 0, isn't it? Okay. Then when you substitute into your formula, even though it's 0, just show it in your working. Just show it. even though we know 0 multiply whatever is still 0. Okay. But in the exam, please be careful. You just show it. You just show the substitution into the Maclaurin theorem. Okay. Even though it is 0. You know the first term is 0. Let's say y kosong, sub kosong, you get 0. Also, you show the 0 that indicate the 0 there. Okay, and then standard series. In this chapter, to expand the series, we have two choices. One is using the Maclaurin theorem. Another choice is using the standard Maclaurin series. We have 4. 1, 2, 3, 4. If the question is open, I put open means doesn't mention a specific method to be used. If can use standard Maclaurin series, we will try to use because it's much easier. It's much easier. Okay, one things we have to look at is that interval of convergence. Interval of convergence. You see, the interval of convergence for these 4 cases, except this one, lone 1 plus x. All the interval is all values of x. See that? Only this one is larger than 1, less than or larger than -1, less than or equals 1. Look at the one of the case here. This is 2018. State the Maclaurin series for cos square root of x up the terms x cubed and its interval of convergence. Okay. Regarding the interval of convergence, actually we have one standard method which is carry out the ratio test. But ratio test, I think I didn't teach my student also. Okay, but in fact, no need to teach lah. No need to teach. Normally, the way they ask for it is that the way that we are able to figure out the interval convergence easily. For example, this one. Because you expand this cos square root of x using the standard series. Standard series. So I'm using this one. This one. Cos. So I sub the square root of x into this here, the x here. Okay, I expand. After that, my interval of convergence, you see, for cos itself is interval of convergence is everything, all values of x. So by right, this square root of x is also about everything. But you have to consider like that. Square root of x must be at least 0. So we try to start from 0 instead of negative infinity. So square root of x must be greater or equal 0 to infinity. So we make the interval smaller. Okay. So normally the way they ask for the interval convergence is the question that we can get it easily by refer to the interval of convergence of this standard Maclaurin series. Okay, without carry out the ratio test. Okay, let us look at question here. Okay, just now this Mr. Lim Boon Kok asked, if given 1 over 1 plus x, can we use binomial to solve it? Depend on the question. If the question asks for Maclaurin series, then you have to use Maclaurin theorem. If the question is open, definitely we use binomial expansion, which is much easier. Okay, number 5. Use Maclaurin series for sine cos obtain the cos sine x up to the terms in x power 4. Hence, integrate this one. Okay, you see how we make use of this standard one. This is the standard one. Here, I sub the the x of the cos as sine x here. So each of the x replaced by sine, by sine. Then the sine x itself also can be expanded as a series. Okay, I just expand until the terms that I need, because it just need up to the term in x power 4. X power 4. Okay, so we try to be smart here. When I expand until x, here the first term is x. Because you're going to square it, okay, definitely you get the x power 4. Okay. After that, x cube is still needed. Because when you multiply with the x, you get x power 4. So x cube is needed. And then for this one, I just need the first x only. The rest I can just ignore. Because the lowest term is already x power 4. X power 4 for this expansion, the lowest term, which is already sufficient. X power 4. So the x minus the rest only, because you can just ignore it. Because this expansion, the lowest term must be x power 4 because it's x bracket power 4. So we just expand up to the terms that is necessary only. Okay, and then you simplify it. Okay, you get it. Now look at the question. Hence, find. For me, we should be alert of the instruction. Find and find approximation. For me, is a two different idea. Find approximation and find. Find approximation are two different ideas. Let us look at it. So because the question is say find, so I must use the infinite series. I cannot truncate the series. If you use approximation, you can truncate it. Potong sama dia, kan? But this one is just fine. So we try to use the full series, which is infinite. Infinite series. So plus ellipses is shown here. Okay, after you simplify it, you still maintain the as a infinite series. Come to integration, you also maintain as infinite series, such that plus ellipses and then plus a constant of the integration. Okay, so this is my advice for this type of question. Unless it say find approximation. Find approximation, you can truncate the series and use the correct notation. When you can find the approximation, then you must use the approximation notation, which is like this, isn't it? Like this. Okay. Now look at this one. State the Maclaurin series for cos 2x. So it's open. Open means whether you can use the Maclaurin theorem or you can use your standard series. So definitely when it is open, we try to use the standard series because it is cos. So you can use the cos, this one, the cos x. Just sub your function of x here into your series. Okay, you can get it easily. Every time the way we write the working is, don't forget the plus ellipses must be shown as the series is infinite. The series is infinite. And then come to find the limit. For limit, the series also must be infinite series. Remember, never truncate the series here. Never truncate. You find the limit. There is no approximation. It must be exactly that infinite series. Okay, so you sub your series as a infinite series here. So don't go and truncate it. All right. After that, you divided by x power 4. You get this infinite series. Okay, Then you show your substitution. The x is 0. Just -1/3 plus 0. Sufficient, enough. And then the rest minus ellipses. Okay. Then you get the answer. Okay, let us go to the chapter 6 now. Chapter 6. Chapter 6. Actually, this intermediate value theorem happened in the chapter 1. But normally it will be asked together with the question in chapter 6. So I put it here to discuss together. In the intermediate value theorem, there are two main ideas. Before we conclude that root exists between an interval, or 0 for a function exists within an interval given. Which are the two? First is the continuous. The function must be continuous in that interval. Okay. Secondly, interval A, you sub the A into the function and sub the B in the function, you should have the opposite sign for both. Okay, then only we conclude there exists a root in that interval. Okay. You see here, I got one case to discuss with you here. Discuss with you. For fx equal to 1/x, by using intermediate theorem, can we conclude fx has a 0 in the interval, -1 and 1? What is your answer? Can or cannot? What is your answer? Any response? So normally we will work up this step, isn't it? We say we find the f -1. Jia said can. Thank you for your answer. Then we get 1/-1 is -1. Then we sub the 1, we get 1. Oh, it looks like it's fulfill opposite sign. So some say yes. Wong say cannot. Wei Jiaxiang say cannot. Fx is discontinuous at x equal to 0. Okay, so Wei Jiaxiang, you're correct. It is discontinuous at x equal to 0. X equal to 0, it is discontinuous. Discontinuous. 1/0 is undefined. 1 is defined. So there are two things actually to determine whether we can conclude there is a 0 in that interval. So one is continuity, another one is the opposite sign when you sub. Okay, look at the second one. If fx is continuous over 0 to 2, given f0 greater than 0, f sub with 2 also positive, both positive now. By using intermediate value theorem, can we conclude fx has no 0 in the interval? Can we conclude? Can we conclude it has no 0? Anybody want to give response? Now this is positive. This also positive. Can we conclude no 0? No root? Nobody want to give response? Nobody want to try? Okay. So the answer is we cannot conclude. We cannot conclude. Because we have no sufficient evidence. Like for example, you see this one. If this is A, this is B. If our graph is like that, our graph, graph. It's like that. Oh, it has two roots, oh. But FA and FB are both positive, oh. Even though FA positive, FB positive, but you see, it got two roots, oh. So we cannot conclude. So not enough evidence. It might be a turning point. Ki Lai said, yeah, true. It might be a turning point. So for intermediate variant, this is how we understand it. How we understand it. And then come to the fixed point iteration method. For given fx, we try to write in terms of x equal to a function, isn't it? Okay, and then we try to sub to get the values of x to the accuracy we want. And then the conversion must satisfy this one. You sub your a, where a is the value near the root. Here, the a is the values near the root. Near the root. For example, you were asked to check between 1 and 2. Okay, you may sub 1, you may sub 2, you may sub 0.9, 0.8, all can, as long as the values is near the root, because we know the root is between 1 and 2. 1 and 2. Not necessarily you say 2 is the best, or 1.5 is the best, not necessary. Who knows the root is near 1, isn't it? For example, this is 1, this is a 2. Who know if the root is here, isn't it? You cannot say I sub 0.5 is the best, not necessarily like that. Okay, as long as the value is near the root, is the suitable values to be used to sub to check the conversion. All right, for Newton-Raphson method, so far I found that it's only once being asked about Newton-Raphson might fail. Here I try to figure out there are 4 situations in which Newton-Raphson might fail. First situation is when you sub the xn into your f prime, it gives 0. When it gives 0, it means that the tangent line is a horizontal. The gradient, the tangent line is a horizontal and never hits the x-axis. Because the tangent line for any curve, if your tangent line, if horizontal, you will never hit the x-axis. It must hit the x-axis for you to look for the next x. Secondly, is the f prime xn is undefined. Undefined means which is 1 over 0 1 over 0. You get infinity The tangent line is a vertical. If vertical, let's say for this example. Okay, kebetulan you take here and then it hit here. It hit here, the next value is also the same values here. It always be there. Xn plus 1 will always equal to the xn. So it won't go anyway. So this one you will fail also. The third is when you sub, it's undefined. Then the iteration terminated. Tak boleh sambung. Terminated, cannot be continued. Fourth, there is a turning point in between the root and the xn. The xn you use is not suitable. Because for example, you see this, the root you want to sort. It is a root. You nak cari root ada di sini. But the initial value you use happen to such that there is a turning point in between the root you want to find and your initial value. You see what happened? If this x1 is x0 here. Then when it should the tangent come to here. Wait, the diagram. X1, the X1, X0, X1 here. And then it just oscillate, X1, X2, X3, oscillate in between the turning point. Then you are not able to reach the root. So roughly these are the 4 situations that Newton-Raphson might fail. Okay, let us go to the question here. show that the equation has a root between 5 and 6. Okay. So here we apply the intermediate theorem. We check sub with 5 positive, sub with 6 negative. So we say the product is negative, or we say both has opposite sign, and try to mention this one. It is a polynomial, so it's continuous. Continuous. Suppose this is the correct one. Because intermediate value theorem, as I said, it has two ideas that must be satisfied. One is the opposite sign, and another one is the continuous. Okay. And then in the working, okay, I go through a little bit fast here. In the working, make sure you show your first substitution into the Newton-Raphson formula. Make sure you sub once. Make sure you sub the second time. Must be shown. Okay. Avoid to use the general one. Avoid to use like this. X1 equal to 5 minus f. Sub with 5 divided by f prime 5. Avoid to use this one. I don't encourage. Very risky one. Very risky. Okay, you try to sub like this. Sub as a full formula. Okay. Then make sure you're working using the correct number of the decimal places. If you find the root correct to 3 decimal places, make sure in your working to find the final one, you use at least 4 or 5 decimal places, or I say plus 1 decimal places or plus 2 lah. Here we need 3 decimal places for the answer. So you must at least use 4 in your working, or you use 5 in your working. Okay, next. Stopping criteria. We should able to stop at the right place. You found x3 and x2 are the same. You should immediately stop. Why you should stop? Because if you continue x4, definitely you get the same thing, isn't it? If you get the same thing, then you are very inefficient. Efficacy tak ada. You are inefficient because you doing something wasted effort. So this one marking scheme also very critical here. You mustn't show your next one. You must immediately stop. Kalau you tertulis, cuba potong sama dia. Cancel up. Okay, and then we see the one more case here. This is the case. Allow me to directly go to the parts that we want to discuss. This is the fixed point iteration method. This one. The formula is this one. Okay. Now we want to find the roots. Find the root. So I start the x0 3. Here I got 2 working. One is using. You look at the question. 3 decimal places. Answer. In my working, here I use 4 decimal places for working. Here I use 5 decimal places. There's some difference here. For 4 decimal places, I do until x6 I stop, because x5 and x8 are the same. So you see these two are identical, then you can conclude the x is 3.596. But if you find decimal places, some interesting scenario happen. Look at the x6. Look x6. x7. X5, x6, x7, x8. According to to what I know, you are supposed to stop at x8. X8. But I myself actually I don't agree. Why? Why must you stop at x8? Everybody can tell me why? the important point is the efficiency. We don't do wasted effort, isn't it? Like just now, I continue X7 is a wasted effort because definitely you will get the same thing. You cuba, you akan dapat benda yang sama. Now, you see, when you get the X7 same as this one, then you already know if you look for X8, it should be the same as X6, isn't it? So if you do it yesterday, actually it's a wasted effort. For me, it's a wasted effort. So this is just my opinion. Okay. But in the exam, how? I just advise you do like this first. You do like this first. If you are not very sure what is the decision, you just change the decimal places you use. You go to 4 decimal places so you can avoid this situation. Okay, let us look at another one. Regarding this trapezium rule. So here, using trapezium rule with 6 ordinates, okay, I go a little bit faster. Time short now. 4 significant figure. So make sure here you use 5 or 6 significant figure. Okay. Then make sure you use the correct notation, approximation. Correct notation. Never mix like this. Never mix like this. I mean 7.638 and then say correct to 4 significant figure. Okay. No, don't try to put in this way. Don't try to put in this way unless you put like this, equal. You use equal. Use equal. Okay. Next thing is the check whether it is overestimated and underestimated. Okay, definitely you see got 2 marks only. We are not going to sketch this graph to see the concavity. You can just make use of the table values. The table values here with the X and Y, you just plot, you get the shape. Normally, if you follow the correct skill, you should get the correct shape. Here you see it's concave upward. Then it's overestimated. Overestimated. Okay, I think that's all I can offer for today. Here's got one question. Equals and approximate. Can I put in this situation? I think I have already answered you just now. So how about interval conversion for inverse cos and inverse sine? That one I have no idea because they want the interval of conversion. You actually you can the answer is using the principal values. But I don't think it will ask the question. My answer is the principal values of the arc sine and arc cos. What else is here? If answer in A is wrong, but the answer in B is correct, is the mark in B will be calculated or just ignore? Normally we check, we mark your papers, follow the sequence. If your solution is in your A part, we check on that. But we come to B. If A is wrong, wrong. If B is correct. There's no recover unless they read for you benefit of doubt. Mark be calculated or just ignore. What else can show? Chapter 4, question 4B, and the C final answer. Chapter 4, question 4. Okay, 1 minute only. Chapter 4, question 4. Got B. Chapter 4, question 4. C, chapter 4. Which question do you mean? Or A, B, C? Or C? Or C here. Okay, briefly, I just go through. Time's out already. So the U is this one. So consider as t tends to infinity, this part 1 over t tends to 0. This part tends to 0. So the U tends to this bracket multiply -1. Okay, I think I have to stop here. Okay, thank you very much for your attention, everybody. Okay, I stop my sharing here. I'll give back my session to our moderator.
Okey, terima kasih Cikgu Chu atas penyampaian yang sangat hebat dan penuh ilmiah. Jadi bagaimana pelajar-pelajar semua? Pastinya apa yang dipelajar hari ini akan dapat membantu pelajar semua untuk mendapatkan keputusan yang lebih cemerlang. Okey, kepada pelajar-pelajar yang mungkin masa cikgu ajar tu tadi terlepas ataupun tak dapat ikut dengan ikut sama, okey, boleh ikuti video rakaman ni nanti di channel kami di Study at MMU ya. Okey, okey baiklah. Nampaknya masa dah sampai penghujung dan mencuburi kita. Okey, sebelum kita berakhir, okey, mari kita saksikan mengenai video MMU sebagai penutup. Okey, saya ucapkan terima kasih sekali lagi kepada pelajar-pelajar semua dan juga Cikgu Chu dan juga kepada pihak penganjur semua. Akhir kata, saya ucapkan terima kasih dan wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.